Hi and welcome to this video about implementing Outbox pattern with Cosmos DB. What is the Outbox pattern? Any service that needs to update its own data and tell outside world about it runs into the same trap. Two systems, two writes, no way to make them succeed or fail together. This is the dual write problem. What happens if we write to the database and then publish the event? For example, save the order, then send a message to the broker. If the process crashes, the pod restarts, or the broker call times out between two lines of code, the order exists but nobody downstream ever hear about it. Inventory never receives or shipping never ships. With Outbox pattern, we can write our document and the event atomically. The event is written to an Outbox record in the same atomic operation as the business data. A separate relay reads the Outbox afterwards and forwards it. The state changes, and the fact that this happened can never disagree. The pattern itself is old and database agnostic. Write your state and I did this record together. Then let something else, a puller, a long tailer, a change feed, pick up that record and deliver it to the queue or broker, independently and reliably. What changes per database is how you get the atomicity and how you tail the Outbox. That's what this tutorial built for Cosmos DB specifically. Why you should consider the Outbox pattern. No distributed transaction, no two-phase commit. You get transactional guarantee between state change and event exist without ever coordinating a commit across a database or message broker. The broker can be down and you still don't lose events. The Outbox record persists in Cosmos regardless of storage queue, service bus, or event hub availability. The relay retries, nothing is lost in the gap. At least once delivery by design, because the relay rereads from a durable ordered log rather than in memory publish call. A crash mid-relay just means reprocessing, not silence loss. Consumers just need to be idempotent. Decouples business logic from messaging infrastructure. Your order API doesn't hold a queue client, doesn't handle broker retries, and doesn't fail an order write because a queue was briefly unreachable. It writes one document and that's it. How transactions actually work in Cosmos DB. Cosmos DB is not relational and it does not give you a cross-container, cross-partition transaction. That's the detail that kills most people's first attempt at an Outbox on Cosmos. But Cosmos does give you something that's exactly enough, transactional batch. The rule that makes this whole pattern work, a transactional batch can atomically create, replace, observe, patch, delete, or read multiple items, as long as every item in the batch shares the same logical partition key in the same container. All operations commit or none do. There is no partial batch. The design move for Outbox on Cosmos is therefore simple. Put the business document and its Outbox event document in the same container and give them the same partition key. In this tutorial, that's the order's own ID. Every order gets its own logical partition and Outbox event that says this order was created. Live right next to it. We will have two containers in the tutorial. Orders. The partition key is order ID, holds two document types distinguished by a type discriminator, order documents and Outbox event documents. Both share the order's ID as partition key, so both can be written in TransactionalBatch. The second container called orders leases. Small container change feed processor uses to checkpoint which partitions and continuation tokens it has already read. The same list container pattern used by any Cosmos change feed consumer. Okay, now let's take a look at our architecture for demo. we have one write, one atomic batch, one change feed, one relay, 5 moving parts, so ambiguity about where an order can get lost. Which means the client with a post request wants to create an order and sends the request to the order API, which is a .NET 10 minimal API. And then the order API creates a document on the container orders in Cosmos DB with basically 2 types of document. One of them is the order document itself, and one of them is the Outbox event. And then we have our Azure function, which is listening to the change feed of the Cosmos DB, and then picks up the order events and then publish it to the Azure Storage Queue. We will jump into the code and I will describe you how these things work together, and then we will go through an example and live demo. Here I am in JetBrains Rider, and as you can see in the solution we have 2 projects. One of them is called Order API, which is a minimal .NET 10 API, and one of them is called Relay, which is an Azure function. So first, let's take a look at what we have in the Order API. We have an order class which represents our order document, which is going to be published in the Cosmos DB, and we have our create order request, which comes from the API. So it has a customer ID and also order lines, which is this a record. It has SKU, quantity, and unit price. For our order documents, we have an ID which we generate, a GUID, and we have our order ID, which is going to be the partition key as we discussed. And the type of this document, we have our customer ID and the order line here, what kind of orders this items this order has. We have the total price, a status, and also the created time. Also, we will have our Outbox event, which has an ID. So we are going to use Outbox dash the order ID, the GUID that we generate in the code, and we have our order ID, also the same partition as the order document basically gets created in the Cosmos DB. We have the type, which is Outbox event, and we have the payload, the object payload, and also the created at. We have also a very interesting property here, which is time to leave. It sets to 24 hours, and after 24 hours this event will be deleted from the Cosmos DB, because by far it should be published to the message broker. After that, let's take a look at our program class. In our program class, we add a Cosmos client to our dependency injection, and after that, here we have an endpoint, a post endpoint, which creates the order for the Cosmos DB. And also we have an order service, which I'm going to tell you how it works. Here in this class, we inject a Cosmos client and we get our container, the orders container. And for the order, we create a GUID for the order ID, and then the order document itself we create from the payload, and then also in the same time we create Outbox events. So we have now 2 documents to insert to the Cosmos DB in the same time in a transactional batch. So here we create our transactional batch, and then we create our items one by one, order and Outbox event, and then send them to the Cosmos DB. That's the whole magic. Okay, now let's see what we have in the Azure function project. So I close all these files, and we can take a look at our program class. And here we are expecting to get storage queue endpoint from the app settings and also the connection of Cosmos DB, which are Azure function trigger needs. And we basically add a queue client of the storage account to our dependency injection here. We have Outbox relay function, which has the Cosmos DB trigger, and here we need to save in what is the name of the database. Our container name in our example is order, the connection string, and this is going to be found in the app settings, and the name of the lease container, which in our example is orders leases, and basically we can also set this property regarding to your need. And also this function will get a list of Outbox documents, and when it gets triggered, we make a loop through the change documents, and if the document type was not Outbox event, so it means that it was a normal document, then we will just ignore it. But if it was a Outbox event, we serialize the message, and then we add the message to the queue in a storage account. And also this is the Outbox document object here at the end of this file. Anyway, all of the source code will be published to the GitHub, and the link of the repository will be added to the description. Okay, let's go to Azure portal and see what we have there. So I am logged in Azure portal, and I have a resource group which is called RG Outbox. Here I have a Cosmos DB and a storage account deployed. For the sake of simplicity, I will not deploy our web API and our Azure function, but if you are interested, you can do it yourself. So I'm going to run those two projects locally, but the results will be the same. So in the other tab, I have here the Cosmos DB basically open. And in the Cosmos DB, we have a database called retail, and it has a container which is called orders. And also we have our orders leases container for the checkpoints. And I will open this one, and currently we don't have any orders item here. And also here we have our, in the storage accounts, we have our orders events queue, which I created earlier for saving time, which is going to basically have events when we create an order in the future. And as you can see, there is no event in the order events queue of a storage account. Now let's go back to Rider and run the projects and fire some example requests to see how these things work. Let's start our order API project. And after that, I will start also the relay project. Okay, as you can see, our Azure function is up and running with the Outbox relay function trigger, and also our API project is up and running in our local environment. And here I have a file, HTTP file, which contains the request. So with this, we can basically fire some request to our endpoint and see what happens in the Cosmos DB and storage account. So let's fire this post request with this customer ID and 2 line items in it. I will fire. And we got here 201 created. So let's go to Azure and see what happened. I am here now in the Cosmos DB. Let's refresh the container. And we got two documents here. One is the actual order document, this one, and the other one is the Outbox document, Outbox message document, which as an ID, we just added here the Outbox and the GUID, but they are in the same partition. And what should happen, and anyways, also we have here our property time to leave, which we set it for 1 day. And what should happen automatically is that we have here a message triggered by our Azure function. If we basically refresh, and the message appears here as we saw it also the same document in the Cosmos DB. And also we can check the logs. If I basically go to the debug and our relay project, we see that basically the relay function was triggered with this order ID. And that shows how we can basically implement Outbox pattern with Cosmos DB with the help of transactional batch. We can also run another request with a different customer ID. This one, I will basically run this one. We should get the same result as the previous one, just to make sure that everything is working correctly. I just make another refresh, and as you can see, we got here 2 extra documents with the new customer ID, and also here we should have 2 events in our storage account. And this brings us to the end of the video. If you are interested about implementing Outbox pattern with Azure SQL database, you can definitely check this video. And I do hope that you enjoyed the tutorial, and see you in the next one. Until then, take care. Bye.